Question 2 on this exercise, that using diagrams, that is circle, we should find the HCF of 288 and 300. Just like I did in the first example, I'm going to express 288 and 300 as a product of its prime factors. Thereafter, I'm going to circle out all the common factors that are there, and in order for me to represent them in a diagram, I'm going to draw two circles which will carry the prime factors of 288 and 300, and there's going to be an overlap. At that region where we have an overlap is going to contain those factors that are contained in 288 as well as in 300. The product of those factors in that overlapped region gives us the HCF between 288 and 300. So let's look for the factors. Let's express 288 as a product of its prime factors. 288 is said to be divisible by 2 because its last digit is said to be a multiple of 2. So 2 into 2 is 1, into 8 is 4, into 8 is 4. 2 is still a factor because of same reason. 2 into 14 is 7, and 2 into 4 is 2. 2 can still divide. 2 into 7 is 3, remainder 1. 2 into 12 is 6. 2 can still divide. 2 into 36 is 18. 2 can still divide. 2 into 18 is 9. Now, you keep dividing with the least common factor until as long as it is divisible by that. Okay, when it is not divisible by 2, then you move to 3, which is the next common prime number. So 3 can divide 9 3 times, and 3 can divide itself 1. So that 288 can be expressed as a multiple of its prime factors to be 2 times 2 times 2 times 2 times 2 times 3 times 3. So we have expressed 288 as a product of its prime factors. We also do same to 300. So you divide 300 repeatedly. 2 can go into 300 because the last digit is said to be divisible by 2. 3 into 2 into 3 is 1, remainder 1, into 10 is 5, into 0 is 0. 2 can still divide for same reasons. 2 into 15 is 7, remainder 1. 2 into 10 is 5. 2 can no longer divide because the last digit, which is 5, is not divisible by 2, or is not a multiple of 2. So we test the next digit, which is 3. Is 75 divisible by 3? Yes, because the condition for divisibility by 3 is that the sum of the digits in that number must be a multiple of 3, or must be divisible by 3. 7 plus 5 is 12, and 12 is divisible by 3. It therefore means that 75 is divisible by 3. This condition is only for a number that is divisible by 3. So 3 can go into 75. 3 into 7 is 2 times remainder 1. 3 into 15 is 5 times. Now, can 3 still go? No, because if you add 2 plus 5 is 7, and 7 is not divisible by 3. So you test the next prime number, which is 5. 5 into 25 is 5 times, and 5 into itself is 1. So that 300 can be expressed as 2 times 3 times 5 times 5. I hope that is okay. We have multiples of 3 2 times. Okay, so this is the factors of the prime factors of 300 and 288. Now let's look at the common prime factors. 2 is there, Another 2 is here. Now we have this 3 and this 3. So if I'm to write this, the common factors, we said they are 2 times 2 times 3. So representing this in a diagram, we shall have this and this. So this is for 288 and this is for 300. So in 280, in the overlapped region, which is this, we have 2, 2, 3. While in the region that has only factors of 288 only, we have 3 set of 2's and 1 3. So this is 2, 2, 2, 3. And for 300, we have 5 and 5. So the HCF now we say is said to be the product of the numbers you find in the overlapped region, which is 2 times 2 times 3, and 2 times 2 is 4. 4 times 3 is 12. So 12 is said to be the HCF of 288 and 300. Kindly like my videos as you watch. While I recommend that you subscribe to my channel and follow me on Facebook if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend you share the link with your friends and families so that they can also benefit from our daily classes. We shall now take the next example on this exercise.